Tonight we talk about a portable radio from the 60s, which is called an Optalix TO-100. So let's talk about that. It is a small portable radio from the late 60s. It's a cute little radio which has two bands on it, namely long wave and broadcast. Okay, so long wave being GO in French, which is Grandes Ondes, and broadcast, which is PO, which means, I think, Petites Ondes, so literally small wave. In any case, the radio seems complete, and I don't see anything broken on the case. Everything is there. So it even has still its carrying strap. But one thing bugs me a little bit, that is that the logo from the front of the radio, so on the little shield here, is gone. I think rubbed off or accidentally peeled off or whatever, but I think I can repair that or restore that without too much trouble. Now, I don't know whether the radio works or not. I think what we should do first is open it up and then maybe give it a soft power up and see whether it works or not. The battery compartment of the radio is right here at the back of it, and there's only one large screw to loosen up. Okay, here we go. Okay, so that's the back of the cover, and there in the center is the screw, which turns out actually not to be a screw but a kind of nut in reverse, a nut screw. It seems a little bit hacked together, so let's see what this is. Ooh, damn it, it's really wedged in. Okay, there you go. So these are two 4.5 volt batteries, and man, do they weigh a lot. Okay, so these batteries are of the type, I don't know if I can see a type on it. Okay, so this type of battery is a 3LR12. The radio has two screws on the back under the cover, which holds this extra cover over the circuitry, and there are two screws, one here and one there, but judging by the state of the screws, I think this radio has been opened quite a few times. So let's say I'm holding my breath here to see what we'll find inside. By the way, I measured these batteries, which are connected together in series, and they only measure 4.3 volts together, where they should give 9 volts instead. So yeah, they're pretty dead. This is one of the screws, which came out of this little hole here. So now let's see whether we can open it up. Yeah, here we go. It seems to come loose. Okay, well, that's nice. Okay, there's a little battery cover. Okay, so this is what's inside the radio. It's not a very complicated mechanism. I count, let's see, 1, 2, 3, 4 electrolytics and 1, 2, 3, 4, 5. Well, I think 5 transistors are in it. Okay, this looks like a reasonably simple setup. Nothing special. Everything seems to be there except the original battery connector. Got the radio hooked up to my small power supply. You see at the back here. Okay. And the voltage is set to 6 volts. Okay. This is broadcast. Broadcast is dead. I mean completely dead. No sound, no nothing. Okay, let's go to long wave. I don't hear much. Let's go to 9 volts. 9.1 volts. Let's try broadcast again. Ah, wait. Well, I think maybe there is still some life in the radio, but what I can tell immediately is that the sound, the volume, actually is way too quiet. And I'm pumping 9.1 volts into it. So yes, there's something wrong with your radio. So let's unmount the electronics from the radio and have a closer look. Alright, I removed the radio from the cabinet, and it's not too difficult to do. So you only need to release 3 screws from the radio, and it slides out. It just slides out of the cabinet. So in any case, here is the PCB of the radio. I don't know if you can see it. This is the PCB, and the dial mechanism looks okay. In fact, if I didn't know better, I would say it looks brand new. Look at how white the cord is. Well, maybe somebody replaced it. That's quite possible. Okay, so maybe some tech worked on the radio and somehow repaired the dial mechanism. The buttons have to be removed before you can remove the whole PCB from the cabinet. And in fact, the buttons are these little caps here. You see here, little aluminum caps. And interestingly, they are held onto the buttons by these little plastic holders I'm showing you right now. Okay, so these plastic holders go side by side on a button like this. Okay, something like that. You have another one on the other side, and since the button caps are hollow, you can slide them over these little holders, and these little holders are sort of squeezed into the cap, and that's what holds the button caps on. Very interesting little mechanism. Oh, and I just discovered that this radio has in fact 7 transistors, not 5. Okay, right away I discover a little thing that is a bit strange, which is that when you look at the speaker wires, you see they've been cut here and there, and the speaker itself seems to have been built in Singapore, and it's a 20 ohm half a watt speaker. Now that doesn't necessarily need to mean anything. I mean, it's possible that they outsourced the parts to some foreign country, somewhere in China or something like that. Even then, yeah. What I also notice is that the shields, the two front shields you see there, the two little aluminum front shields, are simply clipped into the case. So it will just be a matter of unclipping them, so bending these little tabs a little bit inward, and I'll be able to release them, which is good because then I can clean the cabinet inside and out. Okay, so something happened with the speaker that doesn't look very kosher. Alright, I may have found the fault in the radio, so here we go. So you can hear I can receive something on the radio, but you see, suddenly the sound drops. Now watch this. If I move the switch a little bit around, there you go, then it starts working again. So there's certainly a fault around the switch somewhere, the band switch. So let's have a look at that. At first glance, I find very little to fault on the PCB, but I took a good look at the electrolytics, and they might be original. In fact, I think they are the original ones, but I've seen one at least which looks suspicious. Leaky, in fact. So I took the decision to unmount the electrolytics, and unfortunately for me that required releasing the dial wheel, something I really don't like to do, but I think I can get away with just releasing it like this and then unsoldering all the electrolytics on the PCB, which I'm going to do right now with my desoldering gun. So I'm going to do one to show you, and then I'll do all the others off camera. Okay, so here we go. And there you go. That's one. Okay, so it's that easy. You just use a desoldering gun, and if you're lucky, they just drop out like this one. Okay, so this is a 220 microfarad, 10 volts. Now I don't have 10 volt replacement capacitors, but I do have 16 volts, and I think those will do nicely. So yeah, there you go. One capacitor down, 4 more to go. Just when I thought that I would be able to give the radio a clean bill of health, considering the reasonably clean and well soldered state of the PCB, I went ahead and started installing some wires until I wanted to unsolder one of the next capacitors, electrolytics, and look what I found. I don't know if you can see this, but let me zoom in for you. Okay, so watch the solder point. Hang on. So watch the solder point next to the white wire. On the right of the white wire you see a solder point. Well, watch the one just next to it. Do you see the lead moving? It's this one here. Let me show you with my pointer. So look at this lead. This lead right here. This lead right here. Right here. Here. This one is badly soldered. There's the lead is sticking out, and I don't know if it's sharp enough for you, but the lead is sticking out, but it's simply not soldered. It's moving. I think you can just about see it on the camera. Okay, so in any case, finding this fault in on the PCB, I mean, makes me a little bit suspicious of the rest of the PCB. So I'm going to investigate whether there are other soldering points which have the same fault as the one right here. Alright, I finished soldering all the capacitors to the PCB, and I cleaned the PCB. Well, I cleaned off the flux, the soldering flux of the contacts I soldered and a few of the others that were soldered. And there you see all the old capacitors. Okay, so the new ones are all soldered top side. Alright, so let's take the screw for the dial wheel, and you see it's it's a tiny screw, easily lost, by the way, so I'm lucky here. Okay, so this is the screw to attach the dial wheel. So here we go. Actually, I'm fortunate in the sense that the whole dial mechanism looks, well, almost brand new. It's as if it was put in yesterday. It's so clean, and it works so good that, well, I'm a bit astonished, frankly. But it's possible, of course, somebody replaced it some time ago. Okay, well, not too long ago, of course, but really, I'm pleasantly surprised. Anyway, I cleaned off the speaker, I cleaned off the PCB of the residue, the solder residue and everything, and some gunk and dirt. So now let's attach it to the power supply and see whether it still functions. Alright, the power supply is hooked on. We have a little bit less than 9.1 volts. So here we go. Well, right off the bat, I was receiving a radio station. Nice. But there's still something not right. Alright, false alarm. I thought I had it fixed, and it seems after spraying still a little bit more contact cleaner and pushing the buttons on and off a few times, okay, it seems that finally managed to clean up the bad contact that there was. Anyway, I can't see anything broken, I can't see anything loose, and the mechanism seems to work fine. Well, maybe I might have a look at its alignment. I think the alignment is still okay, but since I have all the alignment instructions in the service manual, I think it would be, well, not a bad idea to give it an alignment as well. By very carefully bending the little tabs you see on this front plate, I managed to release it from the top of the cabinet. And as you can see, it was necessary. I mean, it's really dirty. Now you can see there's some oxidation on it, and not to mention a heck of a lot of dirt. So yeah. Now the thing is, actually I wanted to clean it in my ultrasonic cleaner. However, this piece is just a bit too large to fit into my cleaner completely. Now I could try to put it inside, well, obliquely like this, but even then it wouldn't fit right, and I couldn't close the top cover of my ultrasonic cleaner. So I'll have to clean this part by hand. Now, there are a lot of other, let's say, visible, obvious parts that need cleaning still. Like, for example, the dial plate, yeah, which shows the frequencies. That is awfully dirty as well. And that will fit inside my ultrasonic cleaner. That's one. And then we have the buttons, or the knobs I should say, and that is the volume knob, which is plastic and really dirty, so that goes in as well. There you go. And then we have the tuning knob, which is also very dirty. In it goes. And then we end with the carrying strap, which needs a bit of cleaning, like that. And then the small aluminum parts, these are the top covers of the band switches, and they need a bit of cleaning as well. So in they go. Voila. And then we end up with these two little front bezels, one for the volume knob and one for the logo. Okay, these two are just plain aluminum pieces, so in they go as well. Now in there's lukewarm soapy water, and I just used a little bit of detergent. Okay, so it foams quite a bit, but really I just used the tiniest of spray of detergent into it, in it I mean. So what I'm going to do now is I'm going to let it all soak inside the ultrasonic cleaner, and I'm going to set the timer of the ultrasonic cleaner to 5 minutes or 300 seconds, and once it's done I'll have a look and see whether the parts are clean enough or not. If they're not, I'm going to put them in for another 5 minutes, and if still not clean, another 5 minutes, etc., until they are truly clean. Alright, so I let the ultrasonic cleaner clean the parts over, let's say, 30 minutes. So I did a first round of 21 minutes, and then afterwards I cleaned it yet again for 9 minutes. And now let's take it out of the bath. And yes, I did it in 2 times, because after 21 minutes I took it out and there was still a little bit of dirt on some of the most obvious parts of the radio. I mean by that the dial face and the small aluminum bezels. So we're 30 minutes later or thereabouts, so let's take them out of the basket and have a look. Alright, I prepared a little piece of paper to soak up any of the residual soap and water. So let's take out the basket from the ultrasonic cleaner. Oh yeah, the water is quite dirty, you see. It started like just plain, well, translucent water, and look at it now. It's full of yellowish gunk, let's say. So the ultrasonic cleaner did its job, I think. And here are the parts. Okay. So let's lay them out on the paper. Okay. Let's have a closer look, eh? Okay, the carrying strap and the knob. So, at first glance, I would say the operation is a success. Although not entirely. I mean, there is still some dirt on the dial face, and I think unfortunately I will be forced to clean the edges off a little bit manually. Yeah, it was full of oxidation from the large bezel plate, and I think, you know, that's really what caused the residual dirt to remain on the dial face. So yeah, it's only when I started to clean the chassis of the radio and take a closer look at it, that I noticed a couple of things. The first obvious thing was the battery holder that was missing. Now I found in one of my parts drawers, I found exactly what I was looking for, namely a flat battery, so that type of battery adapter. And basically it's an adapter which allows you to connect up two of these, okay? And the way this works is really not so difficult. You can see inside the adapter there are like two contacts, one here, one there. And you see between the contacts there's like a sort of a divider right here. So one end is short, one end is long. Look at the battery, one end is short, one end is long. So you take the adapter and you just slide the pins into it, like that. And then you turn it around and okay, short end is here, long end is here, so you take the battery and you slide it right in like this. Okay, hang on, because I'm trying to do it with one hand, but okay, here we go. There you go. Both batteries are connected. The other thing that was missing, and actually it was so obvious that I looked over it, is the fact that although the cabinet of the radio has an opening, you see there, for an earphone, or an earphone plug really, it didn't have an earphone connector. So I went, again, I dived into one of my many drawers and I found this cute little earplug which I rescued from some old portable radio many years ago. And basically it works. It just needs a little bit of cleaning and perhaps a slight tweak here or there, but it will work, and it fits just like a charm into the opening that was originally made in the chassis for such a plug like this one here, or such a contact really. So I'll be mounting an earphone contact to the chassis as well. I soldered two eyelets to the power wires going to the circuitry, and then I screwed them to the battery holder, which is this thing here, and I put a little bit of heat shrink around the base of the eyelets to insulate them. As you can tell, the space between the eyelets is very narrow, but they're not making contact. I checked and I measure in the mega ohms, so I think that's okay. Now the other thing I did was to install a headphone jack, mono of course, since the radio is mono, and I hooked it up in such a way that of course when there's no jack in the input, then you see those little contacts above it, they are closed, which means that the signal coming through the red wire, you see down below there, goes through that little switch on top and then back out the other red wire to the speaker. As soon as you put in a jack, a headphone jack, into the contact, or into the connector I should say, then that little switch you see up there will open, and that way the sound will be directed straight into the earphone jack and not into the speaker. The other wire, the white wire, is ground. Okay, and ground obviously is common to the speaker and the earphone jack. It looks quite authentic actually. I found another part that failed, which is the on-off switch and volume knob. The original one broke down, so I had to replace it by a new part. The new part is slightly larger, well, it has a slightly larger body and a little bit of a shorter shaft, but I took a good look at it and the knob will still fit and function because the shaft of the knob is long enough to accommodate even a shorter potentiometer shaft. I unsoldered the, well, let's say the holder, the potentiometer holder, from the PCB, and I'm going to resolder it in place like this. That's the original potentiometer and switch, and as you can tell, the switch part, the little lever, let me take a pointer here, so the little lever you see there, okay, and it's part of the base just broke off of the lower part of the potentiometer. You can see the break there, down there. Now it's of course anybody's guess why it broke off, but I would hazard to say that it probably was a kind of material fatigue. I can't say it's a very common fault. I mean, I haven't seen this kind of fault very often, but there you have it. Metal, or rather material fatigue. I replaced it by a new 10K potentiometer. I soldered it in place, and in fact, to mount the potentiometer you see here, I had to first unsolder the leads to the old potentiometer you see over there, and I also had to unsolder this base here, this metal base, which is soldered to the PCB in 4 separate points. I could mount the potentiometer, the replacement potentiometer, and I managed to bend the leads in such a way that they went straight through the openings in the PCB. I don't know if you can see it, but down there. Okay, so you'll see that there are 2 leads to the potentiometer. One lead goes straight to the PCB, so let's say the one closest to the camera. The other one is the other side of the switch and is soldered to the leftmost pin of the potentiometer. Okay, as you know, the IF frequency for the radio is 452 kilohertz, and I adjusted my high frequency generator which is the heat kit over there, to within a few kilohertz of 452. Let me see if I can adjust it a little bit more. Okay, close enough. We're to within 2 kilohertz of the 452 kilohertz. What am I saying? No. We're within. Let me see. It's 1 kilo. We're within 200 hertz of 452 kilohertz. So that's good enough for me. Now, if you don't like continuous tone, rather sharp tone, if you don't want to hear it, then I advise you to well, reduce the volume. If on the other hand it doesn't bother you, well, then by all means keep watching. Okay, so I'm sending a modulated AM signal through a little spool right here, okay, into the antenna coil there. So now the goal is that I tune the IF cans, or transformers, which you see down there. See if I can focus a bit. There you go. So if I can align them for maximum volume from the speaker. Now, I've learned in the past that you should always start with the IF can closest to the output of the radio. And in this case, it's the black tinted one right here. And I'm using a plastic screwdriver to turn the kernel. Ooh, it's really stiff. Okay, so rather than force it, let's move on to the second one. Oh my god, they are all stiff. The yellow one turns a little bit, but it's really very little. Okay, now the white one, let's try that one. Remember, the goal is to make the sound as loud as possible. Well, it was pretty well tuned, I think. Let's see this one. Okay, the alignment was okay, so there's no need for me to go on with trying to align it. It's as loud as it can be. Now remember, you should always use a plastic screwdriver and never use excessive force on these ferrite cores of these IF cans, because they can break in a wink if you put too much force on them. Now remember, the goal of this exercise is to align these little transformers in such a way that reception, in this case on the AM band, is maximal. So in this case I'm pumping in a 452 kilohertz signal with my high frequency generator over there, and it's modulated with a tone. Okay, so if I switch the tone off, you hear nothing. Okay, I repaired the speaker, as you can tell right here, and the reason for that is that the paper, or well, let's say the cardboard of the speaker, was starting to, well, to fall apart, let's say. So what I used was very, very fine silk paper. You could say a kind of tissue paper, but really, really strong paper. That's why they call it silk paper. And I impregnated the cone of the radio with very diluted wood glue. Okay, so, but really dilute. And I cut out strips of silk paper, which I impregnated with the glue, and glued them all around the edge of the speaker, which was really the weakest part of it. And then I lay one layer, as you can tell, of silk paper over the center of the cone. And well, like I said, I impregnated it with very dilute wood glue. And now it doesn't rattle anymore when I make it function. So you can tell the tone is really pure. I designed a small notice label that originally would have been glued on the inside of the radio, right next to the battery compartment. Now, I got my inspiration from a few photos I found on the internet, which showed at least part of the original label that would have been inside of the radio. I have to admit, the label I made is not 100% accurate in comparison to the original label, but I try to approach the design as closely as possible. I used the logo and the lettering for the battery brand, which I found also on the internet, and the brand is Local Oscillator, which is a sort of a word game, since enclenché in French would mean switched on, okay, but Local Oscillator is a sort of a word game on that. Anyway, Local Oscillator is a French battery brand. I think it still exists. And right above the brand you see La Pile, which means literally the battery. Okay, so it means the battery Local Oscillator. And the letter type you see there is, I would say, 70s inspired. It's not entirely 70s, but it's close enough. Now the little logo in the left upper corner is truly the logo Local Oscillator used, as far as I know, in the 70s. Maybe they still use it later. Who knows, maybe they might still use it. But in the 70s they definitely used that logo. A star with 3 rockets above it. And the battery type, so a 4.5 volt battery, like this one here, would have been the battery type GP7 from Local Oscillator. I used some Decal letters to recreate the original logo shield of the radio. You see it there between my fingers, a little aluminum plaque with the Decal letters. I also sprayed it with some clear coat lacquer to protect the lettering. So what I'm going to do now is mount this and all the other parts you see here back on and into the radio. Once that is done, then we'll proceed to mount the PCB. So here we go. Okay. Now we will carefully bend the little tabs over from the logo shield. What do they say? You really need to do that really carefully, because otherwise they will break on you. So there you go. One logo shield mounted. Okay, now I'm mounting the volume knob on the potentiometer and I'm test fitting the whole PCB into the front of the cabinet. And actually, as it turns out, I mounted the volume wheel the reverse way. So before, with the previous potentiometer, this wheel was mounted the right way around, okay? But since the shaft of the potentiometer of the new potentiometer is shorter, I had to reverse the wheel. But as it turns out, and I thought that would be the case, it fits perfectly that way as well. And there you go. So if we test fit the whole PCB in the front of the cabinet, well, you see it doesn't rub and it shows perfectly. Okay, so, and it fits perfectly in the dial face opening. Okay, the speaker is mounted. So the next thing we mount is the PCB itself. Alright, mounted the PCB inside the case with 3 screws. Well, actually no, 2 screws. The third screw is used to keep the dial face, well, the dial face over which the indicator slides, rigidly attached to the PCB. The other 2 screws are in fact one down below here where my finger is pointing, so over there, and the other one is in between the 2 knobs, well, buttons I should say, right there where my finger is pointing. Now comes a very interesting problem, which is that I need to attach the buttons. Remember, those buttons are hollow, you see, and in fact inside those buttons, there are 2 of them, you need to fit a sort of wedges, and I'll show you what I'm talking about. So you need to fit one of these wedges, well, 2 of these in fact, per button. Okay, so these wedges fit inside the button cap like that. Come on, it's a bit hard to do, but you get the picture. Okay, so the wedges fit inside the button, I think like this, and then you need to slide the whole thing over these ends, over these plastic ends. Okay, I did one button as a test. Now I'm going to show you how to do for the other one. And it's really not that difficult once you understand the trick. And in fact, it's easier to do if you fit in the PCB inside the case first, okay? So that it provides extra support. You'll see what I mean. So in any case, you push the other button so that the naked button butt springs out as far as possible. And then you take the 2 wedges, and now you'll see that the wedges have sort of half moon ends. Okay, so what you do is you fit the wedges like this on the butt of, or the axle of the button if you prefer, like this, with the widest side of the half moon to the center of that thing, that plastic axis that's sticking out. So you put in like this. Okay, so, and now the both halves of the button filler are exposed, you see, and they are resting on the central part of the button. Now you take the hollow button cap, which is this, okay, and it's hollow as you can tell, okay, and you slide it gently over these wedges, but you maintain a finger underneath the button axis inside the radio so that it doesn't slide down while you're pushing the knob cap on. So here we go. There you go. Okay, so that's stage 1. Now you gently but firmly push it down. Voila, there you go, and done. I slid the front of the radio onto the cabinet. So now the only thing I need to do is to screw in two long screws. I'll show you what sort of screw I mean. So screws like this. Done. Alrighty. Well, there you go. I mounted all the parts but one back, which is the back cover, obviously. But all the parts are there and accounted for. It turns out that you also need to install first that black cardboard partitioning wall you see down here inside the battery compartment. And in fact, you hear it sounds like cardboard as well. So you have to install those first before you slide the whole black part of the cabinet on top of the yellow. Okay, let's do the shortwave band first. Well, no, not the shortwave, the AM band, I mean. Keep in mind that, as I've told you many times, reception where I live is really poor on these bands, so okay, that was some music. Let's go to long wave. Okay, that's probably the BBC.
Alors lui, par contre, ils avaient un enterrement et on a pu se pencher sur tous ces mois autour de lui.
That's a French radio. Might be Europe 1. Alright, so there you go. We gave the radio a test. Everything seems to work. So this concludes the episode where we restore an Optalix brand TO-100 type portable radio from somewhere end of the 60s, beginning of the 70s. I hope you enjoyed it, and thanks for watching.